Welcome to our series on radome and bumper testing, where we cover everything you need to know about radome testing and the usage of the powerful QAR50. A question I get frequently asked is about positioning accuracy. Therefore, I will explain in more detail how the images are created and what effect an incorrect positioning of the sample has. Therefore, let us focus on the clusters of the QAR50. So the clusters consist of 96 transmit and 96 receive antennas, and they are positioned in a way as it is shown here on the right-hand side of the slide. So the cluster itself is 45-degree tilted inside the QAR because the antennas are 45-degree tilted. So that means by rotating the cluster 45 degrees again, we have a horizontal or vertical positioning of the transmit and receive antennas and can therefore adapt to the polarization of the actual radar. So on the right-hand side, you see the RX antennas, the line of RX antennas and the line of TX antennas that we are using in order to create the image. So for the image post-processing, we can either have the image with the high resolution, which is the QAR50K30, or we can use a weighted aperture, which I explained in a previous video, in order to capture the accurate results. So using the weighted aperture and our large measurement area, what does the tilting actually have for an effect? So let us start with the theory and then let's see how the effect is on the QAR50 on the actual instrument when we perform a measurement. So we have the transmit antennas and the receive antennas here. So this is a two-dimensional image. In order to simplify it, we also have the three-dimensional later, but let us start with the 2 dimensions. So we have the transmit antennas, we have the receive antennas, and if the plate is completely plane, then we have the reflections as shown here above. So now if we tilt the sample by too much, what we do is we have the incident angle is the accident angle with the standard reflectors that we are using, and that means that the energy is being reflected to an area where there's actually no receive antenna. That means if we just look at the result, we could think, oh, that sample is pretty good, but actually we have just tilted it too much and the measurement that we are getting is not correct. So the good thing, and we will see that, is the QAR50 is giving us a feedback that the tilting angle is too high before the actual measurement value is actually wrong. So in this three-dimensional example, again, here we have the parallel sample. So you can see the bright spot is directly in the center. And we also have the tilted sample. So there you can see this bright spot has moved a little bit to the side, depending how you tilt it, left, right, up, down, and you can also trace that movement. So that means if I take that plate, I put it into the QAR50 straight, then I get the point with the highest reflectivity actually in the middle. And if I rotate it, then also the point with the highest reflectivity will move together with the plate. So what kind of effect does that have? We can see that with our measurement result that we did here. So on the left-hand side, you see the result of the perfectly flat, perfectly positioned plate. The measurement circle is in the middle, and we are getting a reflectivity of about minus 7.8 dB. So minus 7.82 dB reflectivity for cluster 1 band 2, so for the 5 GHz band. And if we're looking on the right-hand side, you can see that the maximum of the reflection has shifted to the right. So that means the sample is tilted, in this example about 5 degrees. So that means you can already optically see it. But however, if we look at the result, minus 7.8 dB, we still have minus 7.8 dB reflectivity, even though we tilted the sample by 5 degrees. So you can also see, as I mentioned before, that the QAR50 gives you this kind of feedback and that you're optically seeing something is going wrong in the measurement before the actual measurement result goes off. So that's a great advantage of the imaging that we are using, and this can be used in order to ensure that all the measurements that you are performing are actually correct.